This lecture will cover Chapter 6, Continuous Probability Distributions. There are three distributions we will discuss. The uniform distribution, wherein all of the probabilities are equal over a given interval. The normal distribution, where the probabilities fluctuate significantly over the interval. And the exponential, where they fluctuate, but they don't follow a normal bell curve. Instead, they're all kind of swooped over to one side. So let's start with the uniform probability distribution. The probability is proportional to the interval's length, where A is the smallest possible random variable that can occur, and B is the largest possible random variable that can occur. So the probability density function, or what you're actually going to use to find the probability, is equal to the quantity 1 over B minus A for all values between A and B. So A is your lowest possible value and B is your highest possible value. The probability is going to be the same as long as you are within A and B. Anytime you go outside of that range, A and B, then your probability will be 0. So you see f of x is equal to 1 over the quantity B minus A for all values of x between A and B, but 0 otherwise. And then we have two other formulas on there. The expected value of x is equal to a plus b over 2. Why am I dividing by 2? It's always divided by 2. That's just the formula. And the variance of x is equal to the quantity b minus a squared divided by 12. Again, why divided by 12? It's always divided by 12. It's just part of the formula. So let's see our first example. Slater customers are charged for the amount of salad they take. Sampling suggests that the amount of salad taken is uniformly distributed between 5 and 15 ounces. So this tells us that a customer will have equal probability of selecting a salad anywhere with a weight anywhere between 5 and 15 ounces. Those probabilities will all be equal. So how do we determine the expected salad weight? We use our expected value formula. So our A here is our lower bound of 5. Our B is our upper bound of 15. So we plug into our formula. The quantity 15 plus 5 divided by 2 gives us 10. So our expected salad weight is 10 ounces. We can then calculate the variance of the salad weight, again plugging into the formula. The quantity 15 minus 5 squared divided by 12. Why is it 12? Because it's always 12. And that gives us a variance of 8.33 ounces squared. Now remember, variance is always in units squared. So how does this look if we were to draw a picture? Again, for anywhere between 5 and 15 ounces, the probability is equal. Now, what is that probability? The probability is 1/10. How am I getting that? Go back to my initial formula here for my probability. F of x is my probability of obtaining x, the value that I'm looking for. That is going to be equal to 1 over b minus a for all values between a and b and 0 otherwise. So if I look here, I have values between 5 and 15. So 1 divided by the quantity 15 minus 5 is 0.1 or 1/10. So I have an equally likely probability of selecting a salad weight between 5 and 15 ounces, and that probability is 1/10 for that entire range. Then if I'm asked, what is the probability that a salad weighs between 12 and 15 ounces, the first thing I have to ask myself, are 12 and 15 both within my acceptable range of 5 to 15? Yes, they both are. Okay. So, following my rule, the probabilities are all equal. So the probability is 1/10 for anything between 5 and 15. So the way I'm getting this here, I'm taking that 1/10 and then I'm saying 1/10 times 3. How am I getting that? Well, there's a 1/10 probability that you would want a salad that is 12 ounces, a 1/10 probability you'd want a salad that's 13 ounces, a 1/10 probability you'd want a salad that's 14 ounces, and a 1/10 probability you'd want a salad that is 15 ounces. So the way we can look at this to find your actual probability is that 1/10 times the difference between the maximum of your range and the minimum of your range. So 15 minus 12 is 3. So my range there, my interval is 3, and I'm going to multiply that by the probability of 1/10, and I'm going to get a probability of 30%. So the probability that my salad will be between 12 and 15 ounces is 30%. There's no way to do this on Excel, so we need to just practice more questions by hand. So we're going to go now to question number 1 on your review questions. A random variable is known to be uniformly distributed between 70 and 90. So your minimum value is 70, that's going to be your A. Your maximum value is 90, that is going to be your B. What is the probability density function? In other words, the first thing it wants us to do is write out that probability formula. So let's bring up our solutions. Scroll all the way to the top where I'm answering this. Okay, so A is your minimum value of 70, B is your maximum value of 90. It asks us to write out the probability density function. Well, that formula is f of x is equal to 1 over b minus a. So that's 1 over 90 minus 70, or 0.5. The actual probability density function then is f of x is 5% for all x's between 70 and 90, but 0 otherwise. So anytime you're out of that interval, your probability is 0. Anytime you are within that interval, your probability is going to be 5%. Then B asks me, what is the expected value of x? So I plug into my formula for expected or mean value. So that's A, the quantity A plus B divided by 2. And you see my note here, the 2 and the 12, these numbers are part of the formula and they will not change. So 70 plus 90 divided by 2 gives me 80. My expected value is 80. Then C asks me, what is the variance of x? Again, I plug into my formula the quantity b minus a squared divided by 12. So 90 minus 70 squared divided by 12 gives me 33.33, and I don't have units, so numbers squared. Part D asks me, what is the probability of having a value greater than 96? Okay, well, look at my probability density function. It's 5% for values between 70 and 90. So what is the probability of having a value greater than 96? It must be 0 because it's outside the interval of 70 to 90. So that interval is key. Part E asks, what is the probability that x is equal to 82? Well, 82 is within my interval of 70 and 90, and it's a single value within my interval, so its probability must be that 5%. So 5% because it's a single value within my interval. Part F asks me, what is the probability of x having a value less than 85? Okay, so is 85 within my interval? Yes. 85 is between 70 and 90. But in order to maintain that interval, I can only go down to 70. So a value less than 85 really must mean a value between 70 and 85, because otherwise it's going to be 0. So I take my new maximum value of 85 and subtract that from the minimum value of the interval, which is 70. So 85 minus 70 times the probability that occurs for all values within that interval. So there is a 75% chance that my value will be between 70 and 85. Part G asks me, what is the probability of x having a value between 80 and 95? Well, my interval only goes from 70 to 90. So the probability of having a value between 90 and 95 is going to be 0 because that will be outside the interval. So I wrote it out as two separate questions. The probability of x having a value between 80 and 90, and the probability of x having a value greater than or equal to 90. I also could have written between 90 and 95. That would have been acceptable as well. And you can see for the probability of any variable or outside the interval is by definition 0. So I just made that a 0 right away. And then I go back to my same methodology that I've been using. The probability for a single value within the interval is 0.05, and I'm going to multiply that by the difference in the interval by my maximum and minimum value that I'm looking at that are within that interval. So the 80 and 90 are both within that interval. So 0.05 times my quantity 90 minus 80 is going to give me a probability of 50% that f of x is between 80 and 95. Or sorry, that x is between 80 and 95. How do I know that? Because there is a 50% probability it's between 80 and 90 plus a 0% probability that it's greater than 90 because that would be outside my interval. Then H, what is the probability of x having a value between 83 and 92? Oh, I have here H, I have the numbers 83 and 89. Okay, so 83 and 89 are both within my interval. 83 and 89 are both within my interval. So this is a simple calculation. It's equal to the probability of a single value within my interval times the difference between my range within that interval. So my highest value is 89, my lowest value is 83. Both of those are within the interval, so multiply that by my probability of a value within the interval, and I come up with a 30% probability that x will be between 89 and 83. So I'd like you to practice question number 2 now. Question number 2 says, Delicious Candy markets 2-pound boxes of assorted chocolates. You're given the uniform distribution ranging between 31.8 and 32.6. So those are your A and B values. So A is 31.8 and B is 32.6. And you are asked to find the probability density function first. So write out that actual formula. Make sure you put the 0 otherwise. And then you're asked to do these additional calculations. Now, note in part C, it asks, it asks about something relative to 2 pounds. Note that 2 pounds is 32 ounces. That will be important in understanding this calculation. Okay, so now moving on to exponential probability. Now moving on to normal probability. Normal probability distribution is assumed to be symmetric. Mean equals median equals mode. If we're following a normal distribution, we follow this classic bell curve where we are centered around the mean, and 68.26% of the observances fall within 1 standard deviation of the mean. So mu minus 1 standard deviation and mu plus 1 standard deviation, they fall within that range. 95% falls within 2 standard deviations of the mean, so mu plus or minus 2 standard deviations. And then 99% falls within 3 standard deviations of the mean, so mu plus or minus 3 standard deviations. You will be responsible for understanding this general logic of the normal distribution function You will be expected to understand that it is symmetric and that its mean equals its median equals its mode to allow it to have this look and to have these percentage properties. I will not be requiring you to actually calculate this density function here. In general, what we need to know, the mean can take any value. It can be positive, it can be negative, it can be 0, as long as the mean equals the median equals the mode. This will hold. The standard deviation determines the width of the curve. So if there's more dispersion in the data, then your standard deviation would be higher, and therefore your curve would be flatter and wider. And the probabilities are interpreted as the area under the curve. So same as we did with with uniform probability distribution, but here the probabilities will change. They will not be uniform. They will vary as we move along the curve. So in order to do normal distribution calculations, our first step is always going to be to convert any normal distribution to a standard normal distribution. A standard normal distribution is also known as the z-score. So how do we do this conversion? Basically, your bell curve can have any mean and any standard deviation. What we want to do is convert it to a standard normal where the mean is 0 and the standard deviation is 1. So what we're going to do is use this formula, z equals the quantity x minus mu divided by sigma, where sigma is your standard deviation, x is your value of interest, what you're trying to solve for, and mu is the mean. We have Excel formulas here. These are the newest possible formulas. We're actually going to be using norm dist and norm inverse, so without the s's and without the dots involved there. So norm dist is used to calculate the probability of a given z value. It gives you the probability, which is the area under the curve. And norm inverse is used to compute the z value for a given probability. So you'll be given a probability and you're going to work back from that to get a z value, and you're going to have to then use your formula to work back from there to get your x value. So here's just some playing around, showing you on Excel, playing around with the normal distribution calculations. I don't really want to spend too much time on this. I think I'd rather that we focus on the actual graphs themselves. So if you've noticed here, this is from, these are the tables on the first and second pages of your book. They're not really pages, it's more the opening cover with one side and the next. So the left-hand side and then the right-hand side of that opening cover. And these are provided for you. You will be given a printout of these along with any exam that you have. Other than that, I expect, you have a textbook and you can open those pages to see that. You can also Google standard normal distribution and you'll be able to find these tables from numerous sources online. So this is the greater than table. It gives you the probability that you have a z value greater than something. Now these tables are symmetric. So here you'd be starting with a negative z value because it's less than 0, and it gives you the probability that your z value is greater than that amount. Now it seems kind of strange because you're working with a negative z value, so you go, well, that looks like less than. What are you talking about? Greater than. Remember, it's symmetric, so the same thing applies over here. For a positive z value, it would give me the greater than area. So in general, we refer to this as the greater than table. When you're using it in that way, you just have to remember to ignore the negative sign. It sounds odd, but when we actually use it, it'll make more sense. And then we can go to the additional corresponding table, which I sort of label as the less than table. So here you have a value of z, and it gives you the probability that z is less than that given value. Okay. So remember, when you are working through problems, you will likely have to draw out these curves in order to make sure that you are selecting the right curve. Now, what is the difference here between these two? This one is giving you the values on this side. See this white space over here? The corresponding table, the greater than table, actually gives you the value, the probability in this area. So it's a little bit odd because you only see that on the negative side. But remember, it's symmetric, so the negative side, you can also find the same flip for that positive side. All right, so let's go back to our PowerPoints. There are 3 steps we are going to need to use to solve for our probabilities. The first one is going to be to convert x values, along with the corresponding mu and sigma that were given in a problem, into z values that we can look up in the table. The second is going to be to find the area under the curve in that table. And then we're going to need to translate that into a probability. Now that sounds kind of funny because you're like, well, the area under the curve is the probability. Isn't that what we just said? Yes, that is true, but you may need to convert it depending on which table you looked at. So let's look at this example here. Pepzone sells auto parts for supplies including a popular multi-grade motor oil. When the stock of oil drops to 20 gallons, a replacement order is placed. The store manager is concerned that sales are being lost due to stockouts while waiting for the replenishment order. It has been determined that demand during replenishment lead time is normally distributed with a mean of 15 gallons and a standard deviation of 6 gallons. That tells you your mu, your funky looking u, is 15 and your standard deviation is 6. The manager would like to know the probability of the stockout during replenishment lead time. In other words, what is the probability that demand during lead time will exceed 20 gallons? So we want to know the probability that x is greater than or equal to 20, because probability it will exceed 20 gallons. So your x is going to be 20 that you're going to be using there. So step 1. Convert to standard normal distribution. So your x is your 20. You're solving for probability that x is greater than 20. So substitute in 20 for your x minus mu of 15 because we have a mean of 15 gallons. That quantity divided by your standard deviation of 6 is going to give you 0.83. So that is going to be your z value. You then need to look up this value in the table to find the corresponding probability. You have 2 choices here. You can look at the greater than table and ignore the negative sign, or you can look at the less than table and then do 1 minus the probability that you're given. So here, what they've done is they've looked at the less than table because they probably don't like the ignoring the negative sign. And you'll notice it's a less than table because you see here it's saying probability that that z is less than or equal to 0.83. We actually want the probability that x is greater than or equal to 20. Once we convert that x to a z, we want the probability that z is greater than or equal to 0.83. So looking at the less than table kind of doesn't make sense. Unless you realize that 1 minus that value must give you the probability that you're looking for. So what I do when I see this question, I look at my tables. So go to my z table. I'm going to look at the greater than table. And remember, it's symmetric over here. So I want to look for a value of 0.83 and find its corresponding probability. So the z's are over here. We have, this is your first part, and then these are your extra decimals. So to look up 0.83, I would go down to 0.8 and over, I'm going to scroll up, see which is the 0.3. Okay, over to this column, so my 4th column. So go down to 0.8 and over to my 4th column, and I'm going to get 0.2033. That's 20.33%. Now, this says negative 0.83, z of negative 0.83 has a probability of 20.33%. Now remember, this the probability distribution function is symmetric because this is the standard normal. So the probability that z is greater than or equal to 0.833 is also equal to 20.33%, and I would just ignore the negative signs. Alternatively, I could go down here to this less than table, and some people feel more comfortable with this because you're not seeing a negative sign. So go to 0.8 and over to 0.3, and you get 79.67%. Okay, but that's the probability that z is less than 0.83. You want the probability that z is greater than 0.83, so it must be 1 minus 70.69%. And that's what they've done. That's the way your textbook approached that problem. So they did 1 minus that probability, and they also came up with that corresponding 20.33%. Okay. So let's see how we apply this in some questions. Scroll down. Computer's a little finicky. Okay, so I have some things that are written out for you here on the top. You'll see I'm going to show you how to solve this both using the method that we've just done, which is the by hand method, and then also how to do it using Excel. So we have notes here at the top. They relate to Excel. So we'll scroll back up to look at that region in a little bit. So we're starting on question number 3. And question number 3 says, the miles per gallon obtained by the 1995 Model Q cars are normally distributed with a mean of 22 miles per gallon, so mu is 22, and a standard deviation of 5 miles per gallon, so sigma is 5. Question A asks, what is the probability that a car will get between 13.35 and 35.1 miles per gallon? So I want probability that miles per gallon is between 13.35 and 35.1. My first step is to convert my x values to z values. I use my formula z is equal to the quantity x minus mu divided by sigma. So my first conversion you're going to see in blue. I want to convert that 13.35 into its corresponding z-score. So x is 13.35, mu is 22, and standard deviation sigma is 5. So that becomes negative 1.73. So an x value of 13.35 has a corresponding z value of negative 1.73. Why is it negative? Because the x you're looking for is below the mean. The 35.1 you now see in purple, I'm going to do that conversion. 35.1 minus 22, that quantity divided by 5, is going to give you a corresponding z-score of 2.61. So I want to convert my probabilities in terms of x's into probabilities in terms of z. So the probability that miles per gallon is between 13.35 and 35.1 can be translated into saying the probability that z is between negative 1.73 and positive 2.62. Okay, so I've done my first step. I've converted my x values to their corresponding z values. Then step 2, use the tables to find the area under the z curve. Okay, so we can see how I've drawn this out here. I'm looking for the probability that z is less than or equal to 2.62. And notice that goes all the way to the end if I do that in the if I do that in the less than table, that's going to go all the way to the end of the curve, as you can see with the purple line. So in order to get that bounding between 2.62 and negative 1.73, I'm going to subtract from that the probability that z is greater than negative 1.73. Okay, so here we have that. So I've taken that and I've written it out here. Translate these into the probabilities. Hint, it really, really helps to draw out the curve so I know that I'm going to be doing that subtraction. So the probability that z is greater than negative 1.73. Okay, so I'm going to go to my z tables. This is my less than table, so I want to go to my greater than table. Probability that z is greater than negative 1.73. So 1.7 over to the 3 is 0.0418. Okay, now let's look back here. So that's going to go down here, the 0.0418. I have that located there. Then I also want the probability, and here I'm kind of scrolling back and forth. It's a little difficult and jerky. I apologize for that. So I have the blue part, the 0.0418. Now I want the probability that z is less than 2.62. So I'm going to go to my less than table and find 2.62. So 2.6, this is 2.60, 2.61, 2.62 is 0.9956. Okay, so I'm going to write that down, 0.9956. And then remember, easy way to remember this, you can never have a negative probability. So it has to be 0.9956 minus 0.0418. So my probability that z is between negative 1.73 and 2.62 is 95.38. That means then that my probability that miles per gallon is between 13.35 and 35.1 is also 95.38%. Now I can do this same calculation in Excel using my norm dist function. So the way the norm dist function works, we can go up here. X is less than a value, you use your straight up norm dist. So norm dist and then x, comma, mu, comma, sigma, comma, true. Why is it true? Because in the last chapter it was always false, in this chapter it's always true. Okay, what if you want the probability that x is greater than a given value? Then you'll use 1 minus your norm dist. So norm dist is automatically set up to give you x is less than a specific value. So if you want x is greater than a specific value, you need to do 1 minus norm dist. So you'll see here, I'll start off with my larger value and followed by my smaller value. So subtract, finding the difference between them. Okay, so I can bring up Excel. Equals norm dist. X is 35.1, comma, mu is 22, comma, standard deviation is 5 or 6? 5. I don't know. I think I said 6, or I just had 6 in my head for some reason. Comma, true, minus norm dist of your lower miles per gallon, your 13.35, comma, 22, comma, 5, comma, true. And you're also going to get your same percentage. I just turn that into a percent for my own peace of mind. Okay, 95.36%. Okay, so there's a slight rounding difference when we're doing it by hand, but all in all, same basic process. Question B asks us, what is the probability that the car will get more than 29.6 miles per gallon? So question B, probability that X is greater than 29.6. Step 1, convert that x into a z. So it's the same as saying the probability that x is greater, or sorry, that z is greater than or equal to 1.52. How did I get that? My x is my 29.6, my mu is my 22, and my standard deviation sigma is 5. So that's probability of saying x is greater than or equal to 29.6 miles per gallon is the same as saying the probability that z is greater than or equal to 1.52. Okay, so I go to my tables here, bring them up, go to my greater than table, ignore my negative sign. Probability that's greater than 1.52 is 6.43%. Again, I'm just ignoring the negative signs. If it makes you more comfortable, you can go down here and then just do 1 minus this, okay, because they are the same value. All right, so that's where I got my 6.43%. Now, Excel automatically does the less than, so if I'm going to use norm dist, I need to remember to use 1 minus norm dist here to get the answer that I'm looking for. So enter equals 1 minus norm dist. My x is 29.6. My mean is 22. My standard deviation is 5. And then true. And I can also convert that into a percent. And I'm going to get my same percentage, 6.43%. Where are we? Question C asks me, what is the probability that a car will get less than 21 miles per gallon? Probability x is less than 21. I can put that into my z formula, and my corresponding z is negative 0.2. So I want to know the probability that z is less than negative 0.2. So I go into my table, go to my less than 0.2 is going to be 0.5793. Okay, so we have our values here. I can do the same thing in Excel, and now Excel is automatically set up to do the less than. So norm dist 21, 22, 5, true. Okay, and 42.074. Let's convert that into a percent. So 42.074%. So my same value that I'm seeing here. And then part D asks me, what is the probability that the car will get exactly 22 miles per gallon? Well, when I go to convert into my corresponding z-score, I get a 0. So the probability that x is equal to 22 is also equal to the probability that z equals 0, which is going to be 50%. So z of 0 is 50%. You can see that in both tables. 0 is 50%. You can also do the same in Excel. (22, 22, 5, true). And you're going to get a probability of 50%. Now you know this must be true because you know your distribution is symmetric. So by definition, that must be something that is occurring. Okay, so now I would like you to try questions 4 and 5A and B and 6A and B, following the same methodology. Do them both using the tables and Excel. On the exam, you'll be asked one or the other, but it's best to practice doing both from the beginning. Next, we're going to move on to using that norm inverse function. Now, the norm inverse function, you're given information. Still, you have to be, this is normal distribution, so you always have to be given a mu and a sigma. So here we're keeping up with the same example. So mean is 15 and standard deviation is 6. Now, if the manager of PEP zone wants the probability that a stock out during replenishment lead time to be no more than 0.05 or 5%, what should the reorder point be? So his goal is to get less than 5%. So what we need to do is look up 5% in the table. Look up our 5% in the table, find an area that's corresponding to 5%, and then convert that back to an x value by plugging into our formula here. Now again, in this textbook, they're going to be using the greater than table, so it's going to be a little confusing. You're actually looking for 1 minus 5%, which would be 90%. If your mind works that way, great. It's following the same process. What I actually do is ignore the negative sign and just go to the other table. Let's bring that up, sorry. So I just go to the table where I can find 0.05. So it's roughly 1.645, okay? So somewhere between 1.64, which is 5.05%, and 1.65, which is 4.95%. So I'm just going to estimate a z-value here of 1.645%. It's the same thing that they did in the PowerPoint slides. They're still coming up with the 1.645, but they had to do this 1 minus thing here, 1 minus 0.05 to look up 0.95 in the table. I got the same number by just ignoring the negative sign. So I want to solve for my x value, given that my mu is 15, my z from my table is 1.645, and my standard deviation is 6. So I'm going to come up with 24.87, or roughly 25 gallons. So the reorder point then would be 25 gallons in order to ensure that a stock out during replenishment lead time is less than or equal to 5%. So let's look. We can continue on here, sorry. They can solve this using the norm inverse function. Norm inverse also is going to follow that general idea where things are going to always be looking for the less than sign here. So, So in the upper tail, it's going to do the greater than. So they're looking for the 0.95 instead of 0.05. So let's go and see an example. Look at 5C. A major department store has determined that customers charge an average of $500 per month with a standard deviation of 80. So mu is 500 and sigma is 80. Assume that the amounts of the charges are normally distributed. Okay, C asks us 20% of the customers will charge at least how much? So we want to come up with a dollar amount. So our first step, look up 20% in the greater than table. Okay, well, why am I looking at the greater than table? It's at least 20%. We want to know that 20% of the customers will charge at least what? So we're looking at the greater than table because we want a higher value. Okay, so at least 20%. I'm going to look up 20% in the greater than table. So I go to my greater than table and scroll through here until I find 20. So that's roughly, that would be 2%, sorry. I'm getting stuck there for a second. Okay, so that would be roughly, here we go down here, 20.8 So 8.4 is going to give you a probability of 20.05%. If you wanted to say 8.45 to get, in between this 20.05 and 19.77, if you wanted to go between that 4 and 5, that's fine. I'm comfortable enough saying 20.05% versus 20% as far as the rounding is concerned. So I'm going to come up with 0.84 here. Then I have 0.84 is my z value. My corresponding x is what I'm going to solve for. So I plug in my 500, which I'm using my z formula. So z equals x minus mu divided by sigma. So I plug in my mu and my sigma, and I'm going to use that to solve for x, and I come up with 567.2. Then we can look again at part D, which asks, what is the probability, 5D says 75% of customers will charge less than what? So less than 75%. So I'm going to look up 75% in the less than table. So this is the greater than table, go down to the less than table and find 0.75. It is roughly 0.675. So between 0.67 and 0.678, so I'm going to call it 0.675, is between there is going to give us roughly 75%. So I can go back here and solve. 0.675 is equal to x minus 500 divided by 80. So it's going to be equal to 552.96. And I can plug in corresponding in Excel, but here I'll need to use 1 minus norm inverse because this is norm inverse is automatically set up for greater than, and I would like it to do the less than calculation. Okay, so now you guys can try 6, C, and D. And our presentation will move into the final section, yay, where we're going to be looking at exponential probability distribution. The exponential probability distribution is really interesting because the mean and standard deviation are assumed to be equal, and the distribution itself is highly skewed to the right. We have the density function where mu is your mean, so when you're looking at this, all you're going to find in a question is the x, the probability you're solving for, and mu. There's not going to be any other data in there. And this is telling you that your probability is equal to the reciprocal of mu times e to the negative x over mu. And that is for all positive x because your probability must be positive. And then that's going to give you, your probability function is going to be solved for 1 minus e to the negative x divided by mu. You can also use Excel expondist x comma 1 over mu comma true. All right, and if you do that, it'll give the probability that x is less than or equal to something. So if you do this in Excel, it does probability that x is less than or equal to something. The time between arrivals of cars at Al's full-service gas pump follows an exponential probability distribution with a mean time between arrivals of 3 minutes. Al would like to know the probability that the time between two successive arrivals will be 2 minutes or less. So mu here is 3, and you want probability that x is less than or equal to 2. So I can plug into my function, probability x is less than or equal to 2 is equal to 1 minus e to the negative x over mu, so e to the negative 2 over 3, and you're going to get 0.4866 or 48.66%. I can do the same thing in Excel using the expondist function, where x is 2, 1 over mu is 1 over 3, comma, true. Why is it true? Because it's always true in this chapter. Okay, now an interesting relationship that we can note between Poisson and exponential distributions. The Poisson distribution provides an appropriate description of the number of occurrences within the interval, while the exponential distribution provides an appropriate description of the length of the interval between occurrences. So the number of occurrences within an interval or the length of the interval between occurrences. So they're kind of, they're related to one another that we can see there. So let's look at question number 7. Question number 7 says, the time it takes a worker on an assembly line to complete a task is exponentially distributed with a mean of 8 minutes. So mu is 8. What is the probability density function for the time it takes to complete the task? So probability density function literally just means plug into the probability density function formula. So here's the generic formula. F of x equals 1 over mu times e to the negative x divided by mu for all x greater than or equal to 0. So substituting in for our mu of 8, 1/8 times e to the negative x over 8 is equal, for all x greater than or equal to 0. Question B asks, what is the probability that it will take a worker less than 4 minutes to complete a task? So probability that x is less than 4, we plug into the formula 1 minus e to the negative x over mu. So 1 minus e to the negative 4 over 8 is going to give us 39.5%. I can do the same thing in Excel. X is 4, mu is 8, so 1/8, comma, true. And I'm going to get my same percentage here. And then I can move on to the next question. Part C asks, what is the probability that the worker will take between 6 and 10 minutes to complete the task? And it's just going to be the difference between those two values. So I can write it out here, or I can do the same thing in Excel. The question becomes, well, which do you put first? You don't want negative, so put the bigger number first. Okay, you can now try question number 8. You see your values there. Now remember, Exponent automatically solves for a value less than, so be careful when you are solving part B in number 8. You're going to need to do 1 minus Exponent.